Hey, well, today we decided we were going to go out into the field and create this fence here. So I do have my dynamic duo buddy over there, Oscar, who's going to help us today. But also we thought we'd bring in some reinforcements. So I have my other younger brother, Frankie, who's going to be helping us build this wall. Now, why am I recording this, you ask? That's because most of the stuff that we do when we build has something to do with trigonometry. So today I thought I'd create a lesson as we build this fence using some of the trigonometry. So the topics that we're going to be discussing today and applying in real life here are the Pythagorean theorem. You'll remember the Pythagorean theorem says that in a right triangle, which is what we have here, the legs are called A and B and the hypotenuse is called C. So therefore, if you use the most famous theorem of them all from Pythagoras, it is a squared plus b squared is equal to c squared, and here is the theorem that I bubbled for you. Next, we're also going to be using the special right triangles, which of course in our class we called Fifi and Tara, right? Now, there are Fifis that look like this, which we're going to be using today. This is Big Mama Fifi, and this is Little Baby Fifi here. And I'm going to show you how we're going to use these to make sure that our boards are perpendicular, okay? Now, there is a secondary one. We're not going to be using her too much, but this is Tara here. And Tara, as you can see, looks very different because Tara has a short leg, a long leg, and a hypotenuse. So therefore, we're going to be using very little of her. Most of the stuff we're going to be doing today has to do with Fifi because we're going to want to make sure that the sides are equal. Just like Fifi has her sides, this side and this side here are equal in a hypotenuse. So just to review for you, what were the dimensions of Fifi? Well, they were 1, 1, and radical 2. Therefore, 1, 1, and radical 2. Why is it called Fifi? Well, because it's a 45-45 special right triangle. That's its real name. And of course, Tara also has dimensions. She looks like this. And her dimensions are 1, 2 in the hypotenuse, and radical 3 in the long leg. How will you know where the short leg is and where 1 is? It's always opposite the 30-degree angle here. So now I'm going to be showing you some of the construction that we're going to be building here and how we're going to be applying these topics. But first, I got to get my glasses on because we got to include safety at all times. So there's my glasses. I'm going to be making some cuts, some measurements, and then I will time-lapse our building of our fence here, and I'll stop it periodically to show you some of the things as to how I am applying Fifi and Tara. Okay? Stay tuned. So now we're gonna put the boards here, and so what you're going to be seeing is the first of our vocabulary words today. I'm gonna put this board right here and this board right up here so that we can secure the fence later on. And the trick is to get all of these to be parallel. By the way, do you know what parallel means? Yeah, it means two lines that never intercept, right? So, did you know the sad thing about parallel lines? Yeah, the sad thing about parallel lines is that even though they have so much in common, they will never meet. Isn't that a funny one? Okay, so now let's talk about perpendicular. These lines here are parallel, but they are perpendicular to the post. What does perpendicular mean? Well, it means that there has to be a right angle. And the way I'm going to check is by using this guy here. And yes, there it is, a perfect right angle. The bottom one, yep, there it is, a perfect right angle. That means that this post is perpendicular to the two parallel lines. Therefore, if you remember in class, we have same side interior, alternate interior, corresponding angles, alternate exterior, and so forth and so on. By the way, Do you know that if this post asked this 2x4 here to go to the prom, that this guy 2x4 would probably say yeah? Do you know why? Because this post would have all the right angles to convince her, and this board would then say yes. Ah, you're still not laughing, huh? So right now I'm gonna go ahead and put all these parallel lines all the way down, and then we're going to start putting in our fence, okay? See you soon. All right, so we're ready for the gate now, huh? So I have created a rectangular gate here, as you can see, rectangle. And of course, we got right angles here because rectangles all have right angles, right? So now we are ready to give it some support. And so I've created these diagonals here. And of course, you know what the cut is? Yep, it's 45 degrees. So do you know how many triangles I'm gonna have after I create these 4? Oops, I just gave you the answer, huh? Yep, it's gonna be 4. There they are, all 4 of them. And that's gonna strengthen this rectangle. And then the last thing that I gotta do before I hook up the gate is to create a diagonal. Now, how do we get this diagonal, of course? Well, if you remember, I have a rectangle, and if I want to get the diagonal, all I got to do is find the length of the diagonal using the Pythagorean theorem. That's because a squared plus b squared is equal to c squared. So I'm going to make my measurement, and then I'll be able to figure out the diagonal. The problem is that the diagonal doesn't go all the way across. That's how I would get it. So I'm going to measure it from here to here, but to calculate it, if I needed it to, I would use the Pythagorean theorem. All right, I'm gonna work on this gate, and then we'll put it up, and then I'll show you the finished product. See you soon. Well, all right, as you can see now, here's the finished product. It's the skeleton. It's really, really strong and sturdy. And so now we're gonna go put it up there, and then we're gonna add the fence posts, and I'll show you the finished product real soon. Well, all right, we have the finished product here. Here's your fence and your door that opens to a nice compartment. Why did we do this? Well, because we wanted to have a pen for the dogs to be here, and we added also some additional safety to the windows that lead to little Diego's room here. So 3 hours, 3 brothers, we do it together. The family always helps each other, and you saw some of the applications we did with mathematics. So math is real. It's applicable in real life. Your Fifis, your Taras, your SOHCAHTOA, your Pythagorean theorem. You saw a little bit today, so I hope you enjoyed the lesson. See you soon. Bye.